Hello, Bang Bang Con. So if you take a piece of wire and you move electrons through it very quickly, something interesting happens. You generate electromagnetic radiation. And that's just this basic property of our universe that this happens, which is already pretty cool. And after humans figured out that this is a thing, they started using them for all kinds of applications, right? Here's a diagram of the EM spectrum and all the things you can use it for. It's how X-rays work, it's how your remote controllers work, Wi-Fi, cell phones, and radio. And I wanted to learn more about that, in the beginning of this year. Oops. Well, it will also work like this. So I remembered back to a learning technique I'd heard about by Vi Hart, which is the make 50 of something technique. You make 50 of something in one big marathon. And this is supposed to exhaust your ideas of what you can do in a certain field. Vi Hart used this to learn Python by making 50 small Python programs. And I had already tried this for making 50 tiny video games in a weekend, which was really exhausting and really fun. And so I thought, why not do that again? And this time I wanted to do 50 things with a software-defined radio, which is this little dongle. I also have one here. You can get one for $30, and then it receives a very wide range of radio waves. It comes with an antenna kit. And yeah, this talk is about me showing you what I did that week. It's called software defined because it gives you the raw data and then processes the data on your laptop. So here's what the software looks like. You dial in a certain frequency, like 104 megahertz, and then it shows you this section of the EM spectrum. You can see and hear what's going on there. So in the first days of this week, one very obvious application was to try to receive FM radio, what you see here. And if you go further down in the frequency range, to 6 megahertz, you get in the shortwave radio range, which is pretty interesting because the waves there bounce back and forth between the atmosphere and Earth, so they travel really far. And at night, I was able to listen to radio from China, from a Chinese station, which I found pretty amazing. You can listen to time signals if you know where to look, which make a little beep every second, and then every minute they make a longer beep. So I guess if you're on the ocean or something, you can tune your watch to that. But I want to focus on 3 adventures I did that week. The first one has to do with weather satellites. It turns out there are these satellites orbiting Earth, which scan the surface of the planet and then send down what they see. And everyone can just receive that data. To know where they are, there's also other kinds of software which make predictions on where the satellites will be when. So all I had to do was to pick one and wait until it flew over my head, basically, point my antenna upwards, and then see what I received. And yeah, I dialed in the frequency, was super happy when I received this type of signal, which sounds like tick-tock, and there's software to decode this. It's encodes an image, and my first attempt to decode it looked like this. It didn't work at all. And I'm assuming there was interference from other sources at that day. After that, I tried unplugging my laptop from power. I turned off all my screens. And on my second attempt, I got another picture, which I'm really proud of. Here it is. It's still pretty noisy, but you can still kind of see there's parts of Europe here. There's Italy and France and Germany. And there's this big cloud front coming here from the southwest. So that's useful as a little weather report. And also, I noticed that the signal of the satellite appeared to move in the frequency spectrum. And at first I thought, what's going on there? Until I realized that's just regular Doppler effect going on because the source of the signal moves. And by measuring the offset of this shift and plugging that into a formula for the Doppler effect, which I found online, I could calculate the satellite speed to be 9 kilometers per second. Whoosh. second adventure also has to do with weather data. Weather agencies launch these weather balloons into the sky a couple of times per day to make measurements about like temperature and pressure in the sky. And I wanted to receive one because they send out like their data, right? I also looked in the frequency range they would broadcast, and I think I got really lucky that day because I also pretty immediately like was able to listen to one. Like it transmits a signal every second. It says like where it is and also how high. So there's software to decode that as well. You can see that like the satellite continued rising up and the temperature went down as it rose. So this is like 0 Fahrenheit. And I knew that at some point this balloon would like grow so much, expand because of the lowered outside pressure that it would like pop. And at that point it will fall down back to Earth and like would land somewhere. That's just how these things are used. They are one-time use, built very cheaply, I guess. So I thought, what an amazing opportunity in my like experiment week. I will try to hunt this weather balloon as it comes down. So I took my bike and got on a train to the place where I thought it would land, because it turns out there are maps, online maps, which like predict from the starting location like where they will pop and where they will fall down based on the wind conditions. But that day, that balloon didn't behave as the prediction said. It popped way earlier. It fell down at another place where I was originally traveling like on a train to this town, trying to go through there. But then I got on another train, got back here, and the landing site of this weather balloon was a forest. So I looked around for this weather balloon. I very quickly found a second person who was also looking for this balloon. So this seems to do like a popular sport. And we like teamed up and looked for it together. This was really nice. We didn't find it at first. Like we thought it might have fallen into the lake maybe, or somewhere here. This was the forest in winter. And well, I would have loved to tell you now that we found this balloon and could like take it home or something. But the truth is that we didn't find it that day. And yeah, eventually, like after some searching, we gave up and later learned that a third person had been there even before us and had already taken it. Right. But yeah, as I was like reflecting on this when I traveled back, I thought, well, I didn't find this weather balloon, but maybe I found a new friend. That's also nice. Adventure number 3 happened like on the very last day of my experiment week, and I was like pretty out of ideas at that point. I had like done 45 things or so and was like thinking about what else can I do within like the software-defined radio. And one thing that came to my mind was NFC data. So this is like built into many of your phones probably to like make contactless payments, right? And I wanted just to check if I can like receive any data on those frequencies. So this is the interactive part. Let me switch to the software and start it. And now let's see if I need to lower the gain maybe. Yeah, if you try to just unlocking the phones you have. Oops, yes, do you see these little dots there? That's just like phones waking up and then like trying to find a payment terminal to give money to, I guess. If I try it with my own phone, it's much more visible because I'm closer. Yeah, and I thought, okay, what can we do with this? I like talked to a partner about this and we thought maybe we can like use this to communicate somehow, because like until that point, I only had like received stuff. It's like very heavily regulated who can transmit anything in terms of radio waves, right? So we thought, why not try that? And we like got a library book with a built-in NFC tag. And now, if any one of you has these little pins of Bang Bang Kong with like a built-in NFC, you can like try holding your phone, like unlocking your phone and holding it to the tag. Does anyone have one around? So this was my phone turning on. And I can demonstrate, if you like hold it to the tag, you get this constant signal, right? And so we thought, okay, we could get into different rooms. Like they would hold their phone. Oh, there's one of you sending me data apparently. Yeah, and they would then tap their phone on the library book in the right pattern, and we could send out Morse code. Looked like this, and that actually worked. So yeah, in that case, we were like communicating and sending out data, but I mean, who can prevent you from putting your phone on a book, right? Okay, going to breeze through the remaining things I did. I listened to sensors from my neighbors, like you can get their pressure in their tires in their car, for example. I listened to like Morse code from other countries. You can like spot planes and track ships. Really fun. And at the last day, I noticed that I can just plug the stick into my smartphone and like go mobile with the setup. Also pretty fun. And yeah, what I want to leave you with is two things. Like first, it's pretty amazing to me that all these things I've shown you are like going on at the same time, like around us all the time, right? And it's like invisible to us, but if you have the right tools, you can see them. And the other one is like just in a more general sense, I really like this make 50 things technique. And like if any one of you has like a topic you would like to get into or learn more about, maybe a software, maybe a programming language, maybe consider this technique and like make 50 of something like one after the other to see what you can come up with. Here's the software and hardware I used if you want to try to do that as well. And a blog post with like the remaining 40 things I did. And I'm on blinry.org and on Mastodon. Thank you.